Hello everyone. We'll discuss about chart with PDF using RAG pipeline. The overview of the chart with PDF using RAG pipeline is the goal is to implement a retrieval augmented generation pipeline that allows user to interact with the semi-structured data in multiple PDF files. The system should extract, chunk, embedded, and store the data for efficient retrieval. It will answer user queries and perform comparisons accurately, leveraging the selected LLM model for generating responses. Here we used functionalities requirements like data ingestion, query handling, comparison queries, and response generation, etc. Now we'll discuss about the RAG pipeline, the overview of the RAG pipeline. Here the RAG it implements the retrieve augment generate pipeline for charting with PDFs. A RAG pipeline is a type of natural language processing architecture that enables conversational AI models to interact with structured data such as PDFs. Here, high level overview of how a RAG pipeline can facilitate chatting with PDFs. Here, retrieve, augment, and generate. These are the high overview of RAG pipeline. Retrieve, it implements the pipeline uses a retriever model to search and extract relevant information from the PDF. Augment, it defines the retrieved information is then augmented with additional content or metadata. Generate, it defines the augmented information is then passed to a generator model with produces a human-like response to the user's query. Here some popular techniques that are used for RAG pipeline charting with PDF includes a dense retrieval, latent retrieval, generative models, and some popular tools and frameworks for building RAG pipeline are Hugging Face Transformers, PyTorch, TensorFlow. I hope this provides a help overview of the RAG pipeline. Now here is the program which we have implemented in the Python script for the chart with PDF with using RAG pipeline. This Python script that uses the LangChain library to build a question answering system based on a PDF document. Here is a breakdown of the code. Here the important libraries we are used. The script starts by importing the necessary libraries. Here you can see the import OS2 retrieve question answer. It implements the loading PDF document. The script loads a PDF document using the PDF loader class from LangChain. Okay, next loader equals to PDF loader to load. It implements this loads the PDF document into a list of page objects where each page object represents a page in the document. Setting up an OpenAI embeddings. The script setups up OpenAI embeddings using the OpenAI embeddings. Next API key, it represents it setups the OpenAI embeddings using the OpenAI key stored in the OpenAI API key environment variable. Splitting the text into chunks, this script splits the text into chunks using the character text splitter class from LangChain. Next, here we can see the text equals to text splitter equals to character text splitter. Here you can see, right? This implements this defines, this splits the text into chunks of size 300 characters with an overlap of 15 characters between the chunks. Creating the vector store, the script creates a vector store using FAISS means FIAS class from LangChain. Next, here the DB equals to FIAS from documents, pages, embeddings, right? Here you can see. So this defines the it. Okay, this creates a vector store that indexes the text chunks using the OpenAI chunks embeddings, creating the retrieval question answer QA chain. The script creates a retrieval QA chain using the retrieval QA class from LongChain. Okay, now next QA chain equals to retrieval, you can see, right? uh, okay, now it defines this creates a retrieval QA chain that uses the vector store as the retrieval, asking a question. The script asks a question equals to who is the fourth prime minister of India. Okay, this is the question, and result we need answer. Question equals to this defines that this asks the question who is the fourth prime minister of India. Using this retrieval QA chain, it prints the results. The script prints the results. This prints the results of the question answering process. Okay, now we will the question answer. Okay, you can see here, right? Query result is to result, right? This is the overview of the program which we have implemented. Now somewhat deep about RAG pipeline. We will discuss about somewhat about RAG pipeline. Retrieval augmented generation. The RAG pipeline, it defines the retrieval augmented generation. Okay, now we will discuss some important points or libraries or frameworks, something about the RAG pipeline. Okay. Here in this the RAG pipeline is the natural language processing is one such powerful approach, combines the strengths of information retrieval and natural language generation. In this article, we will explore how to build an efficient RAG system using LangChain, provided a step-by-step guide from initial environment setup to seamlessly invoking the retrieval chain. Whether you are looking to improve search capabilities or generate more accurate responses, this comprehensive tutorial will equip you with the tools and knowledge to get started. Okay, here the setting up the environment. First, let's set up our development environment. Ensure you have Python installed on our system. We will also need to install some dependencies. Open your terminal and run the following commands. Create a new virtual environment, activate the virtual environment, install required packages. And okay, these three are main. Create a new virtual environment. It defines Python -m when b my env. It implements environment. Next one is activate the virtual environment on Windows and on Linux. Install required packages. Create a requirements text file with the following content: LangChain, Fires, CPU, PyPDF, OpenAI, Python, do 10 environment. These install these packages. Now here the building retrieval augmented generation of pipeline. It combines the power of information retrieval with advanced text generation to create informed contextually accurate responses. The basic components of RAG pipeline are query input, document and retrieval, contextual embedding, generative model, response output, etc. And the workflow of a basic RAG pipeline is input, retrieve, embed, generate and output. Now we will discuss about each of them. Now first one is query input. Query input, the process begins with a user input query that specifies the information they are seeking. Next one is document retrieval. This component searches a pre-built document database to find the most relevant documents related to the input query. This is typically done using techniques like a semantic search of FIAS or other similarity search libraries. The retrieve documents provide a rich context for the generation step. Next one is contextual embedding. Convert both the query and retrieved documents into embeddings. These embeddings capture the semantic meaning of the text, allowing for more nuanced retrieval and generation. Next one is generative model. Using a pre-trained language model such as OpenAI's GPT, this component generates a coherent and contextually appropriate response based on input query and the retrieved documents. The generative models used the context from the retrieved documents to enhance this response accuracy. Then final last one is response output. The final output is a generated text that is both contextually informed by the retrieved documents and responsive to the user's query. Next one, we need to see the workflow of basic RAG pipeline. The workflow of basic RAG pipeline is input. There are five. First one is input, second one is retrieve, third one is embedded, fourth one is generate, fifth one is output. Now input it defines user submits a query, and second one is retrieve, right? The retriever searches the document database for relevant document based on the query, and third one is embed. Both the query and the retrieved documents are converted into embeddings. And fourth one is generate. The generative model produces a response using the query and the contextual information from the retrieved documents. And fifth one is output. The system returns the generative response to the user. And there are the important libraries. First we need to load the environment variables and import the necessary libraries. And step 2, create documents. Specify the path of your PDF document. In this example, we use the paper retrieval argument generation for knowledge intensive NLP tasks. Load the PDF using PyPDF loader and split the text into manageable chunks. PyLoader load parenthesis and character text splitter, chunk size, etc. Step 3, create, save and load vector store. Convert the text chunk into embeddings and store them using FIAS. OpenAI embeddings, FIAS from documents, vector save, FIAS load local, etc. And fourth one is create retrieval QA chat prompt. Set up the retrieval based question answering system by defining the prompt and using the vector store. And the last one is invoke chain and print answer. Finally, you can use the retrieval chain to answer questions based on your documents. And last one is conclusion. Okay, we have discussed about frameworks, libraries, functionalities, and how the RAG pipeline has works, and the implementation of the code, and how the code has works. And final, I need to conclude that I would conclude that RAG it defines a retrieval augmented generation system using LangChain. By following these steps, you can build a powerful and versatile system capable of providing accurate and detailed answers based on your document collections. This setup is particularly valuable for applications such as intelligent chatbots, advanced search functionalities, and any other scenarios where precise information retrieval and natural language understanding are essential. Implementing a RAG system can significantly enhance your user interaction and information accessibility, making your applications more efficient and user friendly. Thank you.